Welcome to our YouTube channel. This is Dr. Sengolrajan, Associate Professor in the Department of Electrical and Electronics Engineering from Konganadu College of Engineering. Now we are going to discuss about process, thread, and task in embedded systems. Let me see what is a process. Process, it is an instance of a computer program that is being executed which contains the program code as well as its current activity. The process is nothing but an instance of a computer program which is being executed. It contains both the program code as well as its current activity. The process execution must progress in a sequential fashion. You may have a steps in that similar. So following the steps, we have to progress in a sequential fashion so that the process will get computed. It has only the program code as well as its current activity. Hence, process can be executed in a progress manner or in a sequential fashion. The state during the running of the process, if you say a process is running, means the process may get started. If you say the process is started means whether that process is in running, blocked or finished. Whether the process is in running mode or the process is blocked in between or it may get completed. Suppose if you say the process structure means we can process structure that means whether it indicates a data, a object or a resources or a resources. So if you say a process is in start or process is running means three things is involved. One is process start, another one process structure, and third one is process control block. The process control block is abbreviated as PCB. PCB, a process is run using an operating system means it has to be scheduled and run. Scheduled and run. Operating system gives the control of the computer processing unit on a process request. Process runs by executing the instructions and the continuous changes of its state take place as the program counter charges. Like a program counter, if the process has been continuously changing means the program counter will take the place. The process needs independent resources and memory for execution. The process is an independent one and its text switching is slow. The process is executed including program counter, stack memory, and data selected. The next we will discuss about PCB, that is process control block. PCB is a data structure having the information using which operating system controls the process state. The PCB stores in the protected memory address at the kernel. This is the diagram for a process. A pointer is there and it indicating on which the state the process is running. The process number, what is the process number, and program counter is involved, that is PC is involved. There is a register, memory limits, list of open files. What are the files that is being opened during which the process is being running? The process is being running which files, what is the status of the process, whether it is running or blocked or it is finished, what is the process number, how many process files is processed, where it is stored, that is in stack memory or in register, what is its memory limits. So these are the things that is involved in the process. The next, moving on to threads. Threads. A process is continuing or prolonging the process means we are saying it's as a thread. A thread consists of many codes which is executed sequentially under the state control of an operating system. Thread is nothing but it contains and state information which may be started, running, blocked, or finished. If I say thread means it may contains an information. What information it contains means whether the process is started or running or blocked or finished. Whether the thread is started, running, blocked or finished. So if a thread contains an information of whether started, running, blocked or finished of a state information, then you can call it as a thread state. Thread state. Then if you're saying thread structure means a thread structure has a data, objects, and a subset of the process resources and a thread stack. The difference between the thread state and a thread state and a thread means thread contains an information of a state started, running, blocked, or finished. Thread structure contains data, objects, and subset of the process resources and thread stack. Next comes the diagram for threading. You have having a block for process, which process is running, whether the process is continuing. Thread 1, thread 2, thread 3. Then the process is continuing, whether it is in process state, started, running, or finished. Means where the memory it is being stored in respective stack, then PCB program control block process is being continued. So in that thread, the process thread stack in PCB is in one. A thread, you can say it is a process or a sub-process within a process that has its own program counter, its own stack pointer, and a stack its own priority parameter for its scheduling by thread scheduler. That is, a thread is a process or a sub-process within itself the process. It has an own program counter, PC, its own stack pointer, its own stack, its own priority parameter for which priority the process has to be continued for itself. That is based upon the schedule by the thread scheduler. A thread is a lightweight process or a sub-process which makes use of the application program features of a thread. What are the applications a thread can perform? You can say it is a lightweight process or a sub-process which makes use of the application of the program features. The features it may be, it is a subset of a process. Thread is a subset of a process that contains shared resources and memory. Context switching is fast among the thread. It is an dependent one, not an independent, since a thread is a process or a sub-process within a process that has its own program counter, its own stack pointer, and its own stack. Its priority parameter is scheduling based on the thread scheduler. So it is an dependent, not an independent. The next task is over, process is over, process is over, then thread is over, then next task you are first executed a process, the process continues or prolonged for a while, and it has its own sub-process, it has its own stack pointer, it has its own scheduling. That is nothing but a thread. And next comes the task, the basic building block of a software written under an real-time operating system that is called RTOS. Real-time operating system is the task. What is task means? A similar one to a process. Similar one to a process. Process, what is process? Process, it is a state. It is a state indicating whether the process is started or processed or blocked or finished. So task is the basic building block of the software written under a real-time operating system that is called a task. It is a similar one to a process, but the term task where it is used means it is used in real-time operating system that is nothing but a RTOS. And hence, task can be defined as an embedded program computational unit. Task can be called as an embedded program computational unit. If you want to do a process, you have to assign a task. How a task can be executed, it needs a computational program. Then if there is a computational program unit, how it's done? It runs on a CPU. Then CPU will have a state control of a kernel of an operating system. So we can say task contains a state. What state? Running, locked or finished. Running, locked or finished. Then task has a structure. If you're saying structure, it may be a data or a object or a resources or a control block. So finally, task consists of a series of codes which can be sequentially executed under the state control of an operating system. It is not a dependent process, it is an independent process. Hence, no task can call another task, can call another task. A task can send a signal or a message to another task. The operating system has the ability to block a running task and let the another task to gain access of CPU to run the service course. That means if an immediate task has to be done means already if existing task is doing a process means that task can be stopped for a while and the prolonging or the task has to be started will given priority and that will be completed in an emergency and after the task over the earlier task that is in stand mode will start executing. So that is nothing but yeah, the task can send a signal or message to run the another task. The OS has the ability to block a running task and let the another task to gain access of the CPU to run the service course. Here comes the diagram for how the task is executed. Let me see to the left hand side a new task. You are admitting the task. Then if you are admitting a new task, it is getting ready. It is getting ready. Input output or event completion. When it is ready, then it starts interrupting. It starts interrupting and running. Once running, the process completed, it may comes out exit, then terminated. Terminated. If it is running, then under scheduler means it will wait. It will wait. Then after waiting, it may gets ready. It may gets ready. Again, it's interrupted. Then starts running. Once running, it comes to the exit. Then it gets terminated. So this is the function of a task. Then there are many several task state. One is a new state. What happens in the new state means in the new state, the operating system is aware of the existence of the task. The task has been created and memory allotted to the structure, but it is not ready and not schedulable by the kernel. Suppose if you're saying ready state, what is ready state means the created task is ready and it is scheduled by the kernel, but not running at the present as another higher priority task is scheduled to run has the system resources at its instance. Suppose running state means this is a task which has a control of the CPU. It will normally be a task. which has the highest concurrent priority of the task, which is ready to run. That is called the running state. Suppose if you are calling waiting or blocked statements, the execution of the task blocked in the suspended case, the task requires some resources which is not available. The task is waiting for some signal from the plant. The terminated state means the task is completed and it comes out. That is created task has a memory de-allotted to its subject. It is from the memory. Task has to be recreated. The OS has not been made at the existence of the task, but it is resident in the memory of the computer. The next step, saying that is waiting or blocked state means the execution of the task placed in the state has been suspended because of the task requires resources which is not available because the task is waiting for some signal from the plant. That is waiting or blocked state. The terminated statement, the task computer means. We have been come to an end. We have been discussed what is process, what is the what is task in an embedded system. Thank you. Meet you in the next YouTube next lecture.